Darko, Cobus, Sergey, I'm very happy to welcome you here, and I'm glad that you are presenting such a nice topic today. So thanks you a lot for coming. And
thank you, Vladislav. Thank you very much for having us here.
You're absolutely welcome. And Darko, I prefer to start with you. In Twitter, I've noticed that you've started a fire at your place. So is it cold over there?
It is. I'm actually back home in my hometown of Subotica in Serbia, and we had a couple of days of like -3, 4, 5 degrees. So today is a bit better, but my room has the only form of heating, and that's wood heating. So I'm getting ready for the presentation.
Stay safe and be hot.
Yeah.
Cobus, what about your place?
Well, I'm on the other side of the planet, almost literally, down in Cape Town. So we've got lovely summer over here, and I've actually got the air conditioning running a little bit to not overheat on this side. So I am just outside of Cape Town.
So you are the one who is being cool during this topic. And Sergey, what about you?
I moved to this apartment several months ago, and I don't know anything about heating here, but it's pretty warm. If it will be cold, I will check.
Awesome. Thanks a lot for the checkup. And after this small traveling bit, let's move to the actual talk.
Oh yeah, let's do it.
Thanks.
Okay, thank you very much for that intro, Vlad. And everybody, hello and welcome to. Is this a talk, Cobus, or is this? This is two bald, bearded guys talking about technology. Yes, exactly. So first of all, one of the things you will notice, there is a delay between the two of us. As Cobus is present in South Africa and I'm present in Serbia, we still haven't thought about how to beat the speed of propagation of electrons, aka speed of light. So there might be a 1 to 2 seconds delay between us, but I'm sure we can manage. So Cobus, today we're going to be talking about something very interesting. We're going to be talking about how to test infrastructure as code, or test infrastructure code. We will get into the details, who we are and why should you care, or why should you listen to us, or maybe not. But one of the things you should know that Cobus and I, we look alike. Have you noticed? And we tend to confuse people. So if in midstream you start confusing who's Darko and who's not, remember, I'm the bald bearded one. We're both developer advocates at AWS, but today we're going to be talking about, or trying to answer a couple of questions, right? Question number one is, why doesn't my presentation work? If I click, it works. So what is infrastructure as code? Well, actually, no. We don't want to answer what is infrastructure as code. I'm sure you know what, but why infrastructure as code? Cobus, what do you think? Why infrastructure as code?
The why part is around because I'm tired of writing things down and having these documents that never work. Because that's a bad way of doing things, because you better hope it's right, and you better hope that the person who wrote it doesn't leave the company. Otherwise, you've got issues.
Oh man, you have to love documentation, right? It's the thing that everybody enjoys doing. I always love spending time creating things and then spending time writing what I did. So yes, of course, and you know, if we go back sometime, right? We all remember that this was the way we used to provision infrastructure, right? This is how we used to do stuff. Like I remember my time way back when I was a thing called a server provisioning administrator, whatever that means. So I was tasked with just like yourself, right? Provisioning servers, having servers positioned somewhere. I wasn't racking and stacking, but I was installing operating systems on them, and you have to configure them. And then you have to give them IP addresses, and then you have to redo it because you made a mistake. That was never fun, right? I remember one of the examples I had. I got 500 servers to deploy somewhere in Alaska, and somebody would actually put those servers up in a rack, right? And then what would happen is they would call me up and say, "Hey, Darko, here you go, 500 servers. Please install Red Hat 4 on them, configure them, and you have 6 months." So what happens in 6 months, right? That's like nothing takes 6 months anymore, right? So, and shouldn't, at least not in the cloud world.
No, definitely.
So things have changed, right? How did you do this, Cobus? Did you ever do like server provisioning or the like?
Oh yeah, no. It's like back in the day, we ran Gentoo as that's the first exposure to Linux that I had. So it was a bit of a rough one, but it was great because I learned a lot. And we did remote install. So you'd phone up the data center person, they would go and do the actual machine once it's been racked, put the disk in, and then say, okay, cool. Well, what do I need to run? And then we give them a couple of commands over the phone, and then they would go run those and come back and say, okay, cool, the machine is up and running. We've got your root running, so this is how you can SSH in. Thanks, cool. And we take over. Problem with that was we thought we'd be smart because we had two identical machines that we were going to provision. So we thought, okay, cool. They're running RAID 1, so they're mirroring to the two drives. So we're going to install on one, mirror, take one drive out, put it on another machine, and then just have them both mirror back onto the drive. So then, both machines are installed. We save time. Yes, so the data center tech took out the primary drive on the first machine and inserted it into the slot of the primary on the second. So, on the secondary slot. So basically, we then mirrored two empty disks over the two installs we had just done and lost 3 days.
So, provisioning here caused an outage in production. And I mean, of course, that's nothing to do with you or Cobus or whoever is doing that. It's just, it can be bad luck. It's, especially if you do this a lot, if you try to do it at cloud scale, even if you're not doing this physically, even if you're clicking a button, at scale, statistic comes into mind, right? Statistically, you're about to screw something up, right? But if we can treat infrastructure as well as this, right, as this lovely piece of code, how much better is that, right? Because I always think of this as like a cooking instruction. You write what you want, you explain to the chef, hey, I want this to be configured as such. I want this to be deployed 500 times. And then you can actually sit down and verify, is that okay? Or actually, you can read code and verify, is that okay, right? So that's pretty important, I would say, right? Back in when I started with AWS in 2015, I was blown away by the fact that I can write things in a text editor and have it provision my infrastructure. Oh my God, no more clicking. I love it. So this was a big thing. And it was even it was only Cloudformation back then. I was only dealing with JSON. So when I saw Terraform, I was like, oh my God, this is so better. But yeah, I understand, Cobus, you started with Terraform first, right?
Oh, no. I went everything by hand first. Then I decided to do Bash, and then I started breaking things. Then I went Ansible. Then I forgot to declare some variables, and undefined variable blew up production. Then I moved away from Ansible. Then I went to Cloudformation. Then I hit the 51K limit on Cloudformation at one point, and I didn't fully understand infrastructure as code. And then only did I hit Terraform, and then all of a sudden everything just worked.
Okay. Well, I mean, in general, you did go through a bunch of things. Kind of helped you out on that side. Even when you're doing proper infrastructure code, that can be potentially problematic. So there's a couple of things we're going to be talking about today that can, hopefully address those things. But regarding your doing things manually and doing things in Bash, and this is a great example to explain what is the difference between writing your infrastructure through a Bash script or just using actual frameworks. So infrastructure as code, for those of you who are new to us, infrastructure as code is just a way of defining your infrastructure. Anything you run on AWS, your EC2 instances, your storage, your Lambda functions, your databases, whatever you have, defining them through just a piece of code, a text file that uses a framework or something and just magically creates your infrastructure. But again, you could do this before, like, I can just take my Python script and do some API calls, do some batch, and it works. Yeah, but that's a different way of doing it. You have to take care of state. You have to be understanding that if you create it once, do you want to do it again or not? So proper infrastructure code frameworks actually take all the heavy lifting, even from that side, away from you. So the goal of IAC is basically to make your infrastructure changes very predictable and very repeatable, giving the ability to actually use the exact same tooling and knowledge you have in-house to deploy your infrastructure along with your applications. And of course, Cobus, how many times did you have to replicate production to staging by hand. Oh my God. And it's
well,
all
no. You forget the hope and pray part.
Oh, hope and pray. So yes,
hope you wrote down all. Yeah, you hope you remember everything that you did on staging or dev, and you hope you remember to do it on production, because you often get things like, I remember I clicked something, but
yeah. so infrastructure as code actually helps us deal with this. It helps us quite a bunch in avoiding these kind of problems, potentially problems, right? So so this is quite important. But on AWS, it's not just Cloudformation. It's not just CDK. There's a lot of different things we can do, right? As we mentioned initially, I started with Cloudformation. Cobus also started with Cloudformation, but he ended up using Terraform. But there's also SAM, the serverless application model, or basically it's. I always like to describe SAM as Nation's younger brother. Like it's basically the offspring of Cloudformation. In essence, it's Cloudformation, but it's very much tailored towards serverless applications. Then there's the CDK. Now, Cobus, tell me why Terraform is amazing. I've had I dipped my toes into Terraform, and I love the syntax. I love it. But tell me what's one thing that's kind of sold you on Terraform.
Oh, this is easy. So I started using Terraform when it was version 0.6. And at that point already, it had this beautiful command called Terraform plan. And that sold me. Basically, what that does is you define your infrastructure, you say Terraform plan. It doesn't do anything. It just tells you, I want to create this. And it shows you the delta of whatever previous state versus desired state you have, and say, these are the changes I'm going to make. Which meant that you could actually review infrastructure changes, because before then it was literally a case of, I hope this works, close your eyes, press enter, YOLO. And that's one of the reasons, for example, why I completely stopped using Ansible, because Ansible didn't have a preview function at that point, and I broke production, and it was just too dangerous.
Yeah, so, and I must say that when it comes to Terraform, the first thing that I liked about it is the Terraform destroy. I'm a fan of command line utilities, so anything that has good things. The Terraform destroy thing was so cathartic. Like you do things, you test things out, works, and you're like, there's Terraform destroy, and it all goes away. So, very cathartic, very cathartic. I'm a big fan of that kind of a thing. But we're not going to talk about all these things. Of course, this is a relatively long talk and a discussion, but I don't want us to spend hours and days on all the frameworks. We're going to be mentioning just two things today. It's going to be CDK and Terraform. Now, I'm going to be speaking about CDK a bit later on, why I think it's cool, but I'm a fan of that. I'm very biased towards CDK. I did have, Cobus and I had a stream one day. We were on Twitch. We were streaming, and I was showing off some CDK, and then the next stream, Cobus came and showed up some Terraform, and I was like, oh man, I really need to learn Terraform, because I was there sitting just like not knowing a thing what Cobus was talking about. Like he was showing these Terraform modules. They're called modules, yes, modules. Showing these Terraform modules, yeah, and all of these Terraform commands, plans, and state files. I'm like, what is this? So actually, I spent some time on YouTube actually, and doing some learning of Terraform. And actually, Cobus himself has a bunch of videos to help you get introduced into Terraform. So we'll share all the links later on. But we are very much biased towards infrastructure as code, and I must say I'm a big fan. And this came up before we started this entire talk. I spoke to Vlad about old laptops, right? I'm a fan of old laptops, and both of us have old hardware at home because we're geeks at hearts, right? And anything that you can, there you go, bring up old clunker. Yeah, so imagine today provisioning a multi-million-dollar infrastructure on the cloud using, like an old Lenovo laptop or whatever, like a Toshiba Cobus. You just need a text editor. Anything that runs a text editor will help you do this. So amazing stuff. And this code is the thing that actually, number one, helps you deploy things. Number two, helps you keep consistent. Number three, it's self-writing documentation, right? So that's one of the fun parts about the IC. But speaking of code, Cobus, what else do we do with code? What is very important that we do with code? That not just deploy the code. Yes, of course, we need to deploy the code. We need to write the code. But what's in between?
Well, no, once you've written the code, you save the file, and then you do git-f push master, because you want to, push all of your code directly to master.
Absolutely.
No.
Remember, kids, always commit to production, please. Yeah.
Yes. No. Well, no.
So
I mean, if things software code, you write it, you test it, you test it, you test it, then you push it.
Exactly. So this entire spiel, what we have here today, is going to be about testing code and the importance of why you should test code, but not just running what is called test-driven development. Of course, that's important, but you didn't come here to listen to us about test-driven development. You came here to listen to two bald guys talk about infrastructure as code testing. So we're going to be talking about how can we actually test some CDK and test some Terraform, or actually test some infrastructure, because in the world of the cloud, doesn't matter which cloud, anything you do is an API call. Anything that's being clicked on is actually an API call. So everything in essence is code. So we want to make sure that all the things that we have are capable of being tested and applying all of the best practices to software development and delivery to infrastructure development and delivery. That was a long intro. Before we continue, you may be wondering, who are these two bald guys and why they're screaming at the camera? Let us introduce ourselves. Well, actually, I'll be a good host and let Cobus introduce himself. And why should we listen to him? Cobus, explain.
Okay. Just quickly before that, if you have got a phone or something to do screenshots with, just have that ready, because we will have a number of QR codes during today's session where you can get all the info, because it's easier to get the links from that than trying to write from, a lot of text on the screen. So, who am I?
Correct.
As you can see on the screen, I'm mostly Cobus Bernard everywhere except on YouTube, because I couldn't rename my own personal channel there. Don't ask, complicated. And I am currently a developer advocate with AWS. In previous lives, I have done Java on Linux, and then I moved to C# on Windows, then I moved back, then somewhere in between I did some mobile app development, then ended up doing some game development even. With a game that's on Steam, I can brag a little bit, although the game is not that great, so I tend to not say the title. And then started going into what was known as DevOps, because nobody seemed to like making the code run other than writing it. So I configured servers, firewalls, VPNs, automating things, helping people move on to the cloud, and that apparently has become become known as DevOps. So if you ever need someone to sell you like 5 units of DevOps, just let me know and I can tell you why that isn't the thing you want. And yeah, now I'm with AWS and I help people understand AWS better.
And Cobus, you actually sell DevOps in boxes, right? You provision, you have a farm of DevOps that you sell YAML in boxes or something. Yeah?
No, not just YAML, because DevOps isn't just YAML. It's also JSON, it's also text files.
Okay.
So you can buy them in boxes of 7 and mix boxes of 10.
Okay, and are they organic?
We're working on it. There's a little bit of issue with the test files we've got sprinkled in them. They're synthetic.
Okay. So, and my name is Darko Meszaros. I am basically everything that Cobus has said. You can also call me not Cobus. I am also a developer advocate at AWS. I'm based in Berlin, Germany. I'm originally from Serbia, where I'm actually streaming from now. Welcome to my childhood home. This is full of old technology and old stuff that old Darko pictures as well, if you want. So welcome. Say hello to baby Darko. I'm working for AWS for the last 5 years. So started off in premium support, helping customers like yourself on the phone, on chat, actually solving technical problems with AWS specific services, actually the DevOps services that people like to call them. And now I've been a solution architect also in Germany, helping out the German customer base. And now I'm a developer advocate, where I get to scream at the camera and scream at the cloud together with my buddy Cobus here. And also, we attempt to confuse people quite a bunch on live streams, where we stream at least twice a week on Twitch and YouTube and all that stuff. So, what is it called? Smash the like buttons and the follows and the subscribes, so we can be in touch as we go along. Because hey, we do this a bunch. All right. So Cobus, I think it's time for me to explain to the lovely folks here, what is AWS CDK, or the Cloud Development Kit. So Cobus, I know that you are not, you like CDK, but you are not CDK is not your primary infrastructure of code framework of choice. So yes, I'll try to attempt to persuade you why CDK is just that bit awesome, right? So CDK or Cloud Development Kit is this amazing framework, or it's a toolkit that allows you to actually build your infrastructure, as code, but using generic programming languages, right? So initially, when I started doing AWS and doing infrastructure as code on AWS, Cloudformation was the tool of choice. And Cloudformation, being this at that time just a box of JSON, was great, but I'm very much to argue that JSON is not something that should be written too much, nor read. JSON should be consumed by automated processes and produced by automated processes. But people actually reading and writing JSON, best of things. But JSON is an amazing object notation. Don't get me wrong. But what if myself or you, let's say you are this amazing, wonderful god in Python. You know Python a lot. Like, you can do anything with Python. You can import a Python library and just fly, right? You have this skill set, you have this tool chain, you have folks around, you have the community within your company or organization that you just do Python. Then why do things in JSON? Why do things in YAML when you can use the existing tool set, the skill set and the tool chain actually, and everything else you have built in to build those things? So this is what CDK allows you to do. It actually allows you to provision, actually write and provision your infrastructure as code through the use of Java, JavaScript, TypeScript, Python, C#, and F#, I believe. And also we have I think we should have something coming soon. I think Golang should be coming sometime soon. So it's just great. Plus, you get all the benefits of it being a generic programming language. I always use this example, Cobus, when and I think I showed you this before a few times. How many lines does it take? How many lines of JSON does it take to launch a VPC in AWS Cloudformation? Give it a guess.
Depends. Are you doing it in the forest or not?
Am I doing it in the forest? Yes. So, to create a VPC in AWS CloudFormation, it takes I would say 90-ish lines of code to create a 2 subnet VPC on CloudFormation. Now, it's not that much code, but it takes 1 line on CDK. So some things are very much abstracted for your own convenience. Of course, you can drill in to CDK and make it as fine-grained tuned as much as you want, right? You have all of these capabilities, but you don't have to, right? You have the ability to actually just use a lot of those pre-built constructs and frameworks. Cobus, have you played around with CDK?
I have indeed. I played around with the JavaScript version, though, or TypeScript.
TypeScript, yeah, that's the one we all start with. So, what's your opinion on it? I would like to hear your honest opinion live on a talk.
Oh, unfiltered. Okay. So from having a programming background, I really enjoyed it because it meant that there was no overhead for me to understand how am I expressing myself? Because, code is code. So I really, really enjoyed that part. And also then there was a couple of commands and I can start creating infrastructure, which meant that I didn't have to go relearn an entire new tool and how it worked and the syntax and all of that. So from that perspective, I really enjoyed it because that's one of the things that taught me a lot with CloudFormation back in the day, because firstly it was JSON. JSON is not easy for humans to write with all the string escaping and for things. And secondly, it felt unnatural, the whole, how do I reference it? And also the tooling wasn't that great. So I'm busy editing this massive JSON document. Now I'm using a function to reference something else, somewhere else in the JSON document. Now I need to Control F to jump there, where because with CDK it's code, I can literally just use my shortcut and click, boom, jump into that method or variable or whatever it is I'm referencing. So that was really, really awesome.
Yeah, I would agree. So CDK, again, brings this generic programming languages capability to your code, right? So to your infrastructure code. And one of the things that it also brings, besides these wonderful capabilities, of course, CDK is actually using CloudFormation. So CloudFormation is the tool that brings everything up, because CDK didn't reinvent the wheel and just decided, let me provision stuff for you. CDK, when you do a CDK deploy, it actually goes ahead, generates a CloudFormation template for you, and that is the thing that provisions your infrastructure, just does all the things before, which is great. And to be honest, you shouldn't worry yourself too much about how the actual API calls are made because, hey, you have better time to better ways to invest your time. So, but with this, with the generic programming language capabilities, this is where a couple of other things come into mind. This is where the ability to actually test your code by the means of unit test or run proper test-driven development. And this is what CDK kind of shines in, and I like that because you can literally define things like a unit test. I can create a unit test and say, hey, I want this to be a part of my, I want this test, and I'm going to just, I create a test that I want specific resources available, and then I just try to make that test work. So, and I have a couple of examples here that we can actually have a look at as we go along. So, how do we do testing here on CDK? Or there's, especially when it comes to JavaScript or TypeScript versions, there's 3 types of testing. Now, 2 of these are actually related to JavaScript or the frameworks, and the one is just generic programming validation tests. So I'll explain what all 3 of these are, and I have a demo for both snapshots and fine-grained assertions. So I'm not going to talk too much about the validation tests because validation tests are just generic programming tests. Like you create a validation with just programming logic. So for example, I want to pass on a parameter to my stack, and within my JavaScript code, I just check if that parameter is between the 2 values. For example, I want to set retention period to my I don't know, SQSQ dead letter queue, or 14 days, and I can pass that on as a parameter. And then if I get the parameter that is between 5 and 14, it's okay. If it's anything bigger than that, I will fail my execution directly from my program. No frameworks included. It's literally just programming validation tests. But again, it gives you the ability to do so. To do snapshot tests and fine-grained assertions, I'm actually going to get into that in a moment. But the way you can do this, you basically just need these 2 NPM modules, is the jest module and also the assert from AWS CDK. So Cobus, are you ready to see some code?
Yes. I hope so. You're busy trying to convince me.
So this is going to be a hands-off demo because we want to make sure this is all smooth. So we actually recorded our demos actually today, so they're fresh off the press, which we're going to show off right now. Hopefully, if PowerPoint works like that. Okay, so if I click once again, you should potentially see some code typing. And by the way, I hope you enjoy the terminal. I hope you enjoy Vim because nothing else will be shown. But let's go. So what I'm going to do right now, and lol banner. What I'm going to do right now is I'm going to create the CDK application. As you can see here, I'm actually creating a simple library in CDK and using the TypeScript language. What this does, it actually pulls on all the dependencies, everything I need for a simple blank CDK application, or an app, basically. That's how it's called. So that's all done. And if I'm going to, I just want to install Run with NPM, I'm going to install a couple of modules, the SQS module and the AWS CloudWatch module. These 2 things are basically the things that I'm going to be using in my infrastructure code. For every service you want to use, you need to use those modules or actually install the modules. Excellent. So now let me try to clear. Okay, there we go. So what is Darko going to do right now? Darko is going to create a little file, a TypeScript file that's going to actually define this construct. And this construct is going to be a simple, relatively simple SQSQ, because SQSQs are the fastest things to create on AWS. So basically, this is going to be the file where we create our construct, and I'm just going to, for the brevity of time, paste some code in. So some magic is going to happen right now, and the code is going to be plopped in, as you can see. Again, relatively simple piece of code. I'm not going to here explain how CDK does things, but it creates a SQSQ, and it creates a CloudWatch alarm for the amount of messages in that SQSQ, right? Super simple. Let me save that file, and let's go ahead right now and work on those tests. So what's going to happen right now is I'm going to actually install the jest framework and the assertion framework. So I'm installing those 2 things as modules because I'm going to be using them later on within my tests. Of course, NPM has to happen. All the things need to be installed, and while that happens, I'll grab a sip of coffee. Okay, perfect. And then I'm just going to change the branch because we don't like to use the master branch. All right, couple more edits. The package.json, just because we're using jest, I need to define I need to define a configuration for jest in this case. I'm just telling it what files to look for when running the test. So basically, I'm just setting the file extensions to check for JavaScript files, for .js files in this case. And of course, this is your lovely JSON. By the way, the keen-eyed of you might notice I made a mistake there, but we'll find out that in the future. So let me make a nice lol banner so we just know what's happening right now. So we're going to do some snapshot testing right now, because that's the first piece of test we do. So snapshot tests are basically the way you define a snapshot. You create a snapshot in time and test against it, right? So I'm going to create a blank snapshot test that is going to take a snapshot of my current setup. Of the first time I run it, it's going to create a snapshot, and anything beyond that is just going to fail. So you will see that I failed to paste stuff here. Give me a moment. Now Darko is going to the other screen, and okay, there we go. Perfect. As you can see, it's using all the assertion library for the synth utils, because it's going to actually synthesize this library. It's going to synthesize this construct. So it creates this test called DLQ creates an alarm. It creates a new stack. It doesn't actually launch it. It just creates a Cloudformation stack. It creates a dead letter Q stack, and also runs the snapshot, or to match a snapshot expectation. So this is the test itself. It expects the synthesis to actually match a snapshot. What snapshot, you say? Well, the snapshot is going to exist first time when we run it. Well, not now, because this is where Darko broke his code. So it took me a second here to understand what I did. But Cobus, I forgot a comma, because of course I did. Yeah, in the package.json, comma, there we go. A simple comma fixed it. So again, running npm run build, because we need to compile the TypeScript to JavaScript, and then running npm run test. Now, our initial npm run test will actually create the snapshot. So this will create the first snapshot. This one cannot fail, because this is the initial snapshot, and you will see here in a moment or so that one snapshot has been written. You see the dead letter Q test. The first test is just a blank test that exists. By default, we don't use it at all. So one snapshot has been written. So about those snapshots. Snapshots are actually created within the test snapshots directory. It's actually quite a lot like Cloudformation. So if you look at the code, this looks very much like Cloudformation with the types and the configuration parameters. Basically, this is what CDK kind of generates in a test, and this is against what we are going to be running our snapshot test, right? So let me actually try to break it. So I'm going to actually make a change to my code. I'm going to add something to my construct, my CDK construct here, and I'm going to be changing. I think I'm going to be changing the period from nothing. I think from 5 minutes to 1 minute, but because the default one is 5 minutes. So adding a change, basically adding period, which is going to be just a single minute. Once that is done, I save the file. I need to compile it, again, run npm run build, and then run npm test. So this is going to compile the code to JavaScript and then run the dead letter Q testing. As you can see, it failed. Now, it failed because it expects to match the snapshot, and it doesn't match the snapshot because I've changed it since the snapshot was made. So I'm going to actually go and scroll a bit up, and you will actually see the difference between what is expected and what I got. The period was 300 seconds. Now I change it to 1 minute, and this is actually what fails. And yeah, of course, this is super easy to get into because you create snapshots and you kind of expect those things to work. But you can also adopt those changes by running npm test -u, which kind of just gets the changes back. And basically every other test will just work now because we have updated our snapshot. So that would be snapshot testing, right? And this is fine, right, Cobus? And this is something I see, what's your impression of this? Where do you see this being used, or how do you see this being used?
Well, this is definitely useful in terms of getting started with figuring out what changed, what changes you're making, where something broke, what expected state was. So I like this. I mean, any kind of testing, because like we mentioned earlier, just the rolling out new infrastructure and hoping it works is definitely not a good strategy. So this is a good start for me. I mean, we're getting there.
Yeah, we're getting there, and that's a fair point. We're getting there. This is great, but it's not ideal, right? Of course, because you have to create infrastructure. and then create a snapshot, and then just try to match everything to that snapshot. And that's great if you have like centralized snapshots or something, somebody creates these snapshots for you and you kind of have expected things to be created. But this is not proper test-driven development, right? I mean, this is not in my eyes what I would see as a unit test. So a proper unit test in my eyes would be something like, I actually write my expectations. I tell it, hey, I expect this to exist. And then I have to basically make sure that it exists, right? So I was reading this book by, what's the name of the gentleman? We discussed a couple of weeks ago, the good book about test-driven development by somebody named something BBB. I know you commented that you know the book. I forgot. Is it?
Yeah, clean code. I would take it out of my bookshelf, but my bookshelf is facing the wall because of reinvent.
Yeah, so there's a book. It's basically the book from 2002, I believe. It's like an older book, but it explains test-driven development. So test-driven development for the uneducated is the way you properly do test-driven development. You write a test with certain expectations. You write a test, for example, I expect the output to be hello world. Then what you do, you work on your code until you pass that test. That's it, right? And the same thing we're going to try to do now with CDK. We're going to create an expectation, set something that I expect that something is configured, and then I'm going to add code to my CDK until that works. So this is where we talk about fine-grained assertions, or basically defining specific things, how they should and should not look like, right? So again, magic video, hands-off coding. Let me do that, and hopefully it works. Again, a lot of code. We're going to be using the same code base. The only thing that happened here, I'm going to clean up the snapshots. So I'm going to remove the snapshot test because I no longer need it. I'm going to be using fine-grained assertions in this case. So for this, I'm actually going to import the CDK jest assertion library, right? So if importing AWS CDK /assert/jest, because that's the thing that's going to be used in the fine-grained assertions. Again, the same code, same library, same construct, nothing has changed. We're going to be making some changes to it as we go along. First test. It basically a test that my dead letter queue has to create an alarm. Again, we define a stack. We define a stack for the dead letter queue. And then, of course, we expect to have these resources. And then I define that I need a CloudWatch alarm that has these dimensions. Basically, the queue name is going to be dimension and the value is going to be something. And of course, the metric name is going to be this metric name. So I've created a test. I've created my expectation, what I want from this. Now, let me add a new test here. I'm going to create another test, very similar, but I expect that my stack has an SQS queue, because of course it will, but it needs to have a specific message retention period. My construct by default creates this SQS queue, but I'm just basically saying that once that SQS queue has been created, it needs to have this property. Perfect. Save this. And let's actually, I need to remove the snapshots are something of old, and it's going to complain about snapshots. I'm going to just remove the snapshot directory. Don't need them anymore. Let's go ahead and I think I'm going to be running, the build and the test command. Let's actually build, see if this works. Hopefully I remember this worked from the get-go. It did, perfect. Let's actually run the test now. So the test should fail because of that second test, right? You will see here that it's going to complain. One test has failed, one test has passed. And you will see what has failed. Basically the expectation that the SQS queue has the message retention period set to, that's actually 14 days in seconds, right? Fun fact. So in this case, that's something I have not added to my code, Cobus. I need to modify my code right now to include this. Now, how are you going to do this? Well, it's really up to you, right? It's this is the whole point of test-driven development, where you try to fix it. But I know that to fix this, I just need to add a parameter to my super part of the constructor. Well, to my constructor, how's it called? It's called the property. Is it the properties? It's the
you pass parameter to the parent constructor.
Exactly. Yeah. So the constructor parameter. So I'm trying to remember what's the name of here. It's not message. It's retention period. And fun fact, I was trying this out today and it failed constantly because I mistyped retention. But okay, I've added the retention period right now to duration 14 days. Save this, and hopefully, if all goes good, this should be the fix to our code. again, this is kind of the proper way you do things. Now, if I do npm run build and then run npm run test, the test hopefully should pass. Let's give it a second. Test 1, 2, 3, bam, all good. We have the tests being passed. Perfect. Now let's, of course, write a message. Testing is fun, because of course it is. Testing is fun because it prevents you from breaking things in production. This is kind of the thing. If Cobus had a way to test his the RAID disks before pushing them to production, or actually validate that you're pushing the correct disks to production, you would have 2 days extra of your life back.
Yes. Well, but more like 30 minutes and then 2 days worth of waiting. Gen 2 compile.
That's still fine. That's still fine. Okay. By the way, if you want to get a more insight into this, I've actually made a live stream a long time ago. It's been in March, where I've done a whole hour on this exact topic, where I actually wrote this piece of code. So if you want to check that out in more detail, here's a QR code to my YouTube video on YouTube. To my video on YouTube, where I'm actually doing this live on stream, or actually was doing it live on stream. Okay, before I continue, I've actually we wanted to do this, but we kind of got swept by the talk, or actually I did.
Oh yeah.
Sergey, our lovely expert here. We've asked Sergey if Sergey can actually route questions from the audience to us, or can ask us questions. So Sergey, is there something we should be have there been any questions towards our 2 big heads?
There are no questions in the chat, but I have a few questions for you,
Okay.
if you will. The first one, are you twins or not?
I think it's impossible to tell. Okay, go ahead.
Okay, it's a secret. Okay, go ahead. The second one, say it, please.
Oh. Sorry, there's a bit of a difference. So yes, we are twins, just different mothers on different continents.
Okay, now it's clear for me. And the second one, Darko, you said that you hadn't known anything about Terraform before meeting Cobus. Why haven't he convinced you to use Terraform instead of CDK? What are still killer features?
I think he needs to learn how to persuade me a bit more. See, I'm trying to persuade him to check out CDK and how awesome the testing is. So he will have a chance right now in a couple of minutes to persuade me how Terraform is great. But he did show me a lot of the things when we did our streams together. And to be honest, I love this Terraform syntax. I like that. I call it JSON++. So it's much better than JSON. It's readable. It's actually usable. So I'm a bigger fan of that. But yeah. I'll give Cobus a chance to convince me.
And the last question, sometimes there are different services in different regions in AWS, and you don't test for it because in one region this code can work, and different it can fail. Are there any ways to test this region differences?
So when it comes to CloudFormation, and mind you, CDK actually creates CloudFormation code. There's a tool called CFN lint, CloudFormation linter, which doesn't just lint your code, it actually checks your code against the CloudFormation spec. So if you point the linter to a template and to a region, it will actually check if that's going to be able to launch in that region. Is that service available? A typical example is like if you want to launch an EC2 instance of the type T3, you can do it in most of the world, but you cannot do it in the new regions. Like in Cape Town, there are no T2 instances. There are no T2 instances in Cape Town. There's only T3 instances. So the CloudFormation linter will actually make sure that works. So that could be one part of your testing pipeline for your code.
So I should add linter at the end of this pipeline.
Yes, exactly.
Okay, that's it for me, I think. At least for now.
Okay. And thank you very much. And in this case, so this kind of is an amazing segue to the next part of our presentation. And I'm going to mention some pipelines because pipelines are also important. I think pipelines are the things that define testing or code delivery, right? And Cobus having pipelines means you have DevOps, right?
Of course, that's the secondary. You buy that sort of along with a units of 10 in your box. We always throw a free pipeline in.
Yes, please do. Pipeline is just what we call gratis with your DevOps. But pipelines are here to actually help you treat your infrastructure code as any other code, right? Code is important. So infrastructure code is nothing different than your application code because, in the modern times, especially when it comes to services and all that stuff, infrastructure, especially in the cloud, is part of your application more than ever, right? Your API gateways, your Cognito user pools, your DynamoDB tables, all of those are infrastructure technically, but they're very highly to your applications. So you have to test that as well. So I want to just speak about something before I hand over the stick to Cobus. Testing for code just to make sure the code is working or doing the desired thing is fine, but we also need to test for outcomes. So moving our code down the pipeline, like if we commit our code, right? This is where Darko or you or Cobus puts some code in the Git repository, and then you run some unit tests. This is where the entire linting and test-driven development, unit testing happens. But then you actually have to test things, right? And what is the best way, Cobus, to test infrastructure code?
You test in production.
Hey, well, yeah, you test it when it's deployed, right? So you have to actually deploy it. So the test phase here actually is the thing that you push the code somewhere, you actually deploy your infrastructure to a testing environment, of course, or even to production, right? Doesn't matter. You provision it. You actually make the infrastructure happen. Then you use something like a Lambda function or an external thing or inspec or whatever kind of a tool to actually verify, has it properly launched? Because, yeah, of course, one thing is to test if your code is compilable. Yeah, that's fine. But is your code actually doing things? Is it actually achieving the business outcome? So from actually testing for like, do I have the EC2 instance or not, to testing for business outcomes, checking, is your endpoint URL available? Are you receiving customer data? Are you getting, are people using your application, etc.? So this is one of the parts of the path to have in order to have a properly, fully successful. And once that is done, once your verifier has said, oh yeah, that's fine, let's continue, and let's move on to the production, right? With that, I think it's time for my good buddy Cobus to convince me of something, and also explain a bit more how things work. Well, outside of AWS tooling. So Cobus, let me just put this. Actually, I'm going to be changing the slide. So Cobus, tell me, what is Terraform?
Okay, so just quickly before we get into this, there was a quick question in the audience about whether or not we've got an opinion about Pulumi. And basically, we have got a very strong opinion when you ask us, should I use Terraform or Cloudformation or CDK or Pulumi in this case? And the answer is yes. Because pick the tool that works for you and just do infrastructure as code in some form, learn from it. If you do decide to move to another tool that better suits the problem space, like I did, for example, going through multiple different ones until I found, okay, Terraform works for the way my brain works, do that. But try at least two of them. Any two you think might be the way, but two different-ish ones to do that. So getting back to Terraform, what is Terraform? Well, Terraform is a infrastructure as code tool by a company called HashiCorp, and you might have heard of them from products like Vagrant, which is a mechanism to configure VMs and run them easily, or maybe Packer, where you build some VMs with them. More recently, you might have heard about Vault or Console, and they just launched Waypoint, and I cannot remember the other service that they just launched. But in any case, they've got a whole bunch of open source projects that you can use. So next slide quickly. Sorry, there's going to be a bit of a delay because I'm on the other side of the world. So Terraform, you write in what's known as HCL, or HashiCorp configuration language, and it's JSON-like in the sense that it's, when you look at this, it looks like JSON, except there's no commas at the end of the line. It's got a couple of other interesting things, like, for example, if you look in the second block, that AMI, where it's got a direct reference to some kind of data variable or something there. It's not escaped anything. It's just, so it's JSON-like, but it's not JSON. So let's quickly dig into exactly how Terraform does things. So click. Inside the top, what you'll see is you define a provider. Now, in Terraform terms, a provider is something where you want to create some infrastructure or want to create something, because there's some very interesting use cases for Terraform, which isn't necessarily infrastructure even. AWS is one provider. There are, I think, more than 100 providers actually currently available public, and you can also build your own provider if you want. And what that does is it tells us, there's a lot, because you can even do things like, I know you can configure Cisco switches with them, and other hardware and network things. It's like, because the benefit of Terraform is that they built a engine that defines the graph of all the resources you want. So it figures out the dependency graph of all these things that you want. And then it says, okay, cool, what did you have? What do you want? Figure out the difference. And that's the base engine of it. So then once you've got that in place, then you just start building specific providers and plugins on top of that, because that mechanism is exposed to you via the actual core functionality of Terraform. And that's what makes it awesome.
In this case, Terraform actually runs the API calls for you, right? So Terraform makes those needed API calls no matter which service you're running. That's what Terraform does, right?
Yeah, Terraform does those calls, and in the case of AWS, it's actually using the Go version of the SDK, I believe, to do those calls. It's embedded into the actual Terraform code.
Cool.
Yeah. And I mean, as Terraform itself is also written in Go, which means you've got a single binary that you deal with. There's no multiple installs or dependencies or anything like that. It's a single binary, which is awesome. So now that we've told Terraform, this is how you communicate with your provider, which is AWS, the next part is to define some resources. And this is where you go, for example, we say we've got an AWS instance we want to do. We give it a friendly name like web, and then we start giving it some configuration values of what to create. Now you can see there where the orange arrow is, that's where you give it some information, which is not a string. It's data.awsmi.ubuntu.id. So the question is like, okay, what's that? Well, this is where you can actually use another core building block, because you can imagine for an AMI, which is an Amazon machine image, it's this long ID string, which represents a specific machine image that was created somewhere in AWS's account or in, let's say, Canonical's account or somewhere else. So next slide quickly. Sorry, that slide was missing. So what that data source is the ability to do a lookup. So you can actually configure it to go, say, do a search for me, for example, a Ubuntu 2004 64-bit image in a specific region. And it'll go find it and then expose it as that data resource. But as you start building, back to the next one. As you start building up resources and more resources, there we go, this one. And the reason I made this slide so small is that you're not supposed to read it unless you want all the Easter eggs that are in there. Is that you're going to end up with lots and lots of these little resource blocks. So this is where initially I started going, hey, Terraform is great, but this isn't really fixing everything. And, it's getting cumbersome. It's getting a lot of nitty gritty things. And I keep copy pasting things and fixing them. So how do we fix this? Well,
I think Cobus froze. Is that Cobus that froze? Okay, not sure if that's Cobus or myself, but how to fix this? I know how to fix this. You fix this by using Terraform modules. At least that's my guess here, because what happens here is that you can actually group different resource combinations into things called Terraform modules. And you thought I didn't know Terraform. I don't know Terraform. I've learned a bit of Terraform, but at least this is how much I know. So yes, you can actually group all of those things that Cobus was mentioning, all of those different types of code, different resources, different things, into something called Terraform modules, which are in essence just modules that you can kind of reuse and plug in. And Cobus is back.
Yes.
We missed
things fail all the time, in case you're wondering.
So Cobus, I've explained what modules are, but please correct me.
Okay, so a module is when you take all of those different resources and you wrap them, and then you have, similar to a class inside a programming language, you define input variables, output variables, and you smash them into a smaller chunk, and you can reuse these blocks. Darko, did you do it right? Did you say smash?
Yes. No. Not smash, but I said bunch.
I'm going to watch the recording.
Smash.
Okay.
Is smash the official term? Is that the proper ecclesiastical term in this case?
Well, it could be. It could be. We can make it so. But in any case, moving along swiftly. So now we've got modules, and one other thing that's missing is how to define some variables. And you can have a lot of different types. So just There we go. This is just an example of a list variable type. You can have lists, you can have maps, you can have strings, you can have individual integer values. So you can actually just access these different variables. And this will be important a bit later in the demo because you want to, for example, pass variables into these sets of Terraform files where you configure things. And then based on those, you want to make sure that this actually was created the way it was supposed to. So let's get on to the actual demo now, which is the fun part. But just before you play on the demo, you have to pause.
There's going to be a remote demo with Cobus far away in the world, demo playing computer via stream, via St. Petersburg. So you thought landing the rover on Mars was difficult. So go ahead, and I'll pause for a second. Why am I pausing?
Yes. You are pausing because I want to explain how I went about this testing first. The reason is there are, as you should know with anything related to coding, multiple ways to do different things. So when you start searching for how to test Terraform, you'll probably come across a thing called TerraTest, which is by Gruntworks. And it's actually a library they wrote that you write Go code to actually do your infrastructure testing and make sure that your Terraform is creating the infrastructure the way it's supposed to. I didn't want to go that route because I personally am not that good with Go. So I've thought, I don't want to learn another coding language to do this kind of testing. That's too much effort. And it also didn't feel like it was testing the right things because I want to make sure that the infrastructure is actually there where it is. So then what I decided to do is I will show you how to test the actual infrastructure that's been created. So what we're going to end up with is we're going to run through a whole process of using a library called AWS Spec, which is built on top of RSpec, which is a Ruby library, which for me is familiar because I did a lot of time doing Chef, and with Chef you do a lot of testing, and testing in Ruby is normally in Spec or RSpec or one of the testing libraries like that. So that to me was like, okay, I know this already, it's not that hard. And even if you don't know it, the syntax is not hard, as you'll see in a little bit. So you can hit play so long because there's a bit of a pause in the beginning. If you want this code repo, I will be pushing the code directly after this talk. So it's not there yet. It's just an empty repo because I want to keep you entertained and waiting for it and to listen to me. Otherwise, you're just going to go play with a nice new toy. So what we're going to do is we are going to go test. Oh, yeah. We are going to be testing some very basic Terraform infrastructure. So what I did is I created a file with a VPC in it using that module I just showed you, and I defined the AWS provider at the top, and then also a variable for the actual VPC name, and then what you'll see next is the chunk in the module where I created, and then ultimately at the bottom what we have is there will be some variables that I do, or outputs rather, output of the variable value as well as the actual created infrastructure, because we want to pull some values out of that in a moment at some point and actually look at it. And then what we do is we go ahead and say Terraform plan, which will tell you what the difference is. Now I've already created this infrastructure. So this is going to run now for a few seconds, and we don't have to worry about it wanting to change anything because the infrastructure is already there. We created it. So this will now take another second or two, and then we will see at the bottom in nice green, it'll tell us no changes to be made. So I'll just highlight that and cool. Okay. So now we've got this. So how do we go about testing it? Well, we've got our infrastructure, and we can obviously start writing some very basic tests. Now, given that this is built on in spec, you create a spec file. So what we do is we create first secrets. Sorry, there's a bit of a lag here. We need to configure this to be able to use. Now, if you've got the AWS CLI configured, you can actually do that and actually use that, but you can also use the secrets file, and that's important for a bit later. So the AWS secret file or credentials file is in your home directory .aws/credentials, and that it'll use that by default. But there's a reason we do this, and we're going to get to that a bit later. This file is configured with a secret key and a access key as well. And as you can see, you really do not want to share these, which is why I do not share them on screen. Please do not commit this file. Please do not share this file. This is where you get into trouble. So we're going to create a very, very basic spec test. So we're just going to call it first test once I can realize how to type, .spec. And being a spec file, what you do is you use that helper file that does the secrets first, and then we've got a basic test that says describe the VPC with the name VPC, and then it should exist. And then we just bundle exec reg spec like you would do with normal reg specs. And as you can see, boom, it worked. Now, this tells us that, we just wrote a test by hand without querying the Terraform code at all. So this validates that what we know, and we explicitly told it this is what we want to create. This is great, except there are more configurations on a VPC, and you don't want to be writing all of this out by hand. So what you can do for the first one, similar to the snapshots, is that you can actually say, generate me all of the values for an existing VPC. So what you can see I passed in there is the actual VPC ID, and I'm running that AWS spec generate command and piping it into the VPC spec.rb file inside this directory. So this will take a few seconds to run, because now what's happening is doing multiple API calls in the background, and it is busy gathering all of the information of this existing VPC. So this just helps us get started with defining the infrastructure, because you can go write this out by hand, but it's going to take a while. Now you can see we put a whole bunch of tests over here. We're checking, does it exist? The VPC should be available. It's got a specific ID. But we're going to start ripping some things out here, because testing for a specific ID is not very useful. I mean, that ID is going to change every time we generate the infrastructure, so let's rip those out. We don't need those, because that's pointless testing. It's literally just you're going to waste your head and bang your head against it and doesn't give you anything. So let's see. We're now testing. We've got the CIDR block. We've got some routing tables. We've got a VPC attribute set, etc. So let's just quickly make sure that our testing is working. And as you can see, boom, green all across the road, all across the board at the bottom. Things are going well. We know that a VPC name is called DevOps VPC, but if you decide to call it something else, wouldn't it be nice if you could actually just pass that value somehow directly from your config into the test? And this is where we get creative, and we actually pipe out and run a Terraform command and pipe the output into a specific variable. And we have to do a gsub to replace the string quotes for something we'll see in a little bit inside a Docker container, but that's just to future-proof it. But basically, the backtick there says take this and run this command, which is Terraform. So we say Terraform output and give me the VPC name, which is that output variable that we could define initially. So we can actually say, so the input variable, the variable we have configured, we immediately pipe to output. So we know this is the variable we feed into our module. Then we also feed that same variable into our testing that actually tests the actual infrastructure. And now what we can see is happening is that if I go and change that value, then I don't have to come change my test again, because that's the value that I passed through. Because remember, we want to validate that what I input is actually being created and outputted. And as you can see here, it's working. And this is great. But as with all things, we want other people to use it. So how do we do that? Well, easy answer, chuck it into Docker. And just quick highlight there and shout out at the bottom, you can see that the new AWS ECR public repo is launched. So there's a link up there that you can use and actually pull the repo image from. So this is just some basic Docker housekeeping. I'm going to use Docker build for this to keep it simple. I've got a gem file where I install AWS spec and rake. And I've got them in separate steps just to make use of the caching and make it a little bit simpler. And also install Terraform inside the actual container, because I need to do it for that command that I want to run. Then also rip out the gem file.lock, because that always causes issues if you just copy it across between the different platforms you're building. And now what's going to happen is I just go ahead and say Docker build. And if all goes well, and I think with this build it did, what it does is it copies all the files from this directory into the container when we build it, does all of the other configuration, and then runs the same steps that we had before. And this means that you don't need Ruby on your system. You don't need to install any dependencies other than Docker, which makes it super easy to do, which also means then when you get to putting this into your code deployment or code pipeline of some kind, or whatever pipeline you're using, it's very easy, because most things are able to execute a Docker command of some kind. And as you can see there, it actually finished and it ran the test for us inside a container. And we are now 6 minutes in, and you just tested physical infrastructure that exists. There are two things I want to call out here. Firstly, the GitHub repo that you can access, but also specifically that GitHub repo where AWS spec is, because this is an open source project that makes this testing possible and really makes it easy to do. And it's got a whole lot of other directives there in terms of how you do it. And also, please, just again, go create that secret spec file, and do not create that or save that file in your Git repo or commit it or push it anywhere you don't want to. Preferably, you don't want to use it. There are ways, once again, that you can configure everything to use IAM roles and not have to do it. You can even pass those into the container. Slightly more interesting, but yeah. And that is it for my demo. I specifically went through the Terraform bit quite quickly, because I've got a nice intro series on videos on YouTube for you to go look at if you want to, if you're interested in learning Terraform from scratch.
Yeah, definitely. Cobus has this on his channel, and you will be able to see the name of the channel later on to wrap up. But Cobus, I love this. I've never seen this, to be honest. Like I've used Inspec way back when I was also doing some Chef. I was doing Inspec and checking has Chef actually configured it, have wrote an RSpec, and I'm a fan of RSpec because it's so human readable. It says like it expects to have or doesn't have or those things. Yeah. So man, I wish CDK had this. Hello, CDK folks. Hi, can you implement something like this? Yeah.
So I just want to put it out there, Docker. You do know that you can test your infrastructure with this as well, because this does call against the AWS API. So no matter how you create your infrastructure, you can go test it with this.
Yeah, but AWS spec, the gem by Mr. Kilo, that is the thing that generates the spec files for you up front. So that's something I really do like. So that kind of took my interest. So yes, and this GitHub repo will be available after this event. Cobus will push it to the link before. But if you have not had a chance to get the URL, let me give you another quick chance. Can I do it like this? Like that? What? If I do, yes.
I mean, well,
this is the QR code you
I'm
need
lucky.
to snapshot
You can just search for me
to get that GitHub, or just search for Cobus. It's very easy to find.
Yeah, I'm unique. Nobody else has my name. Yeah.
There you go. Okay. Cobus, I'm a fan of this. I like this. I'm definitely going to try to play around with RSpec a bit more for infrastructure. Like I've never even thought about using this kind of things. So pretty cool. And I think for the end, we just have some homework for you. Now this is basically something we want you to do once you go. Of course, beyond clicking the links we sent and checking out Cobus's repo and smashing the likes and subscribes on all the social medias, whatever. When you write your infrastructure, make sure to spice up your toolkit. Now, will you do that from your text editor by doing all of those fancy linting tools and specs and all the stuff, or you're going to actually be creating your unit tests or using something like RSpec to actually verify has your infrastructure been deployed successfully or is it actually running what you want it to run. Pipelines are important. We have not shown proper pipelines here, but yes, of course, make changes through infrastructure code changes through a CI/CD pipeline, because yes, you will thank us in the morning for that. You don't want a bad change to go to production just because, hey, I'm going to commit to main. So be careful for that. And of course, as all things, have fun. Have fun writing good infrastructure code. And this kind of ties into the question about Pulumi versus other things, or Terraform versus other things. As Cobus says, yes, you should use an infrastructure as code tool. Doesn't matter which one. The one that fits your use case is the better, because I've said this many times. The best programming language is the one you know and you'll feel most comfortable with. So make sure to have fun when writing good, secure infrastructure code with all the tests built in, so you don't kind of fail. With that being said,
just for having fun on AWS, in case you were not aware, yes, you can insert emojis inside tags and names of things. Yes. So you can have instances with just emoji names. It is a lot of fun. Go do that.
Of course, absolutely. And you can use Cyrillic as well. So there we go. We tested out in Terraform. So if you want to hear more about us or get more similar things like you've seen today with a bit more less defined topics, make sure to subscribe to the YouTube channel. It's called Not Cobus, Not Darko. It's basically a YouTube channel where Cobus and I both stream at least twice a week on various tech topics, from actually geeking out around old tech and talking about DevOps and infrastructure as code. So we like to do this at least an hour and a half on stream on Twitch and also on YouTube. But all the videos are available here. So if you want to check us out a bit more and try to make us company live on stream, please do so. We would love to have you there as well. With that being said, once again, we would like to thank you and invite you to follow us on the social medias. I would like to thank Cobus for being part of this. I would like to thank the DevOps folks for accommodating us. Before we go, I'm not going to go away yet. We have some time. We're going to take the questions and all that stuff. We want to say that both of us are developer advocates at AWS. And if you're interested in being a developer advocate at AWS and you speak some Russian, please do reach out to us.
Yes.
We're looking for somebody that may fill this position. So absolutely. So folks, Sergey, we are ready for the questions. Some, if they're not.
I have a question. Actually, you asked my question about RSpec because I also didn't see it before, and my question was: is it possible to test Cloudformation and CDK with RSpec also? Because it's a good tool. Maybe we should write unit tests for CDK and also RSpec tests for the production. It's a good idea. I have a question about costs. Sometimes new people, new DevOps write very huge scripts and CDKs and Cloudformation, and it can cost a lot. Is it possible to fail a test if, for example, I use some expensive services or my costs exceed some number, how to deal with it, or it's not possible?
I would say it's possible. Go ahead, Cobus. I'll let you answer this one.
So, because Terraform is awesome, yes, you can with Terraform. There is a open source library by Anton Babenko. He's also very big in Terraform. I can't remember the exact name, but it estimates what the cost is based on the resources defined inside your Terraform files. So what you can do is you can use that library to actually do that and say if in your pipeline you can build something in for safety, saying if you're over a certain amount, then throw some kind of error.
It's very useful feature. Darko?
Yeah. So from my perspective, when it comes to deploying things to production, you should always be careful that production is the thing that makes you money. So barring production from running because of money is always a problem. I would agree with when you're deploying testing environments. One of the things you should also always do is make sure that the testing environments are just a bit smaller than production, right? That's why you use variables like in Terraform with Cobus, where you define a smaller instance type or a smaller cluster size or whatever. So this is what you would do, and you can actually prevent those things from being launched. For example, in CDK, you can have specific. One of the things I like to have in CDK is when I launch a test environment, I just have predefined sizes in CDK. So if somebody just launches CDK in test environment, it will launch only with smaller sizes of instances and all those things. So you can implement those things. And of course, if you want to go like all the way, you can actually have a look at your estimated costs with some magic, like the same like Anton made for Terraform, right? You can have queries of costs and all those things, but you will not be able to get instant cost information about your current status because the cost on AWS, it's always delayed by a bit. So it takes a moment or so for it to show up how much this has actually cost you.
Darko, Cobus, Sergey, thanks a lot. It was an awesome talk.
Thank you
and
very
thanks
much.
a lot for all the awesome questions.
Thanks.
So
thank you very much.
I'm really glad and I've learned a lot. So thanks a lot. Quite a pity it's not from the forest as in your video YouTube channel. So if anyone is interested,
I have some wood.
Awesome. So thanks once again. But if you do have any questions, you can find our speakers in discussion zone, which is a Zoom chat down below, or you can still ask any questions in Telegram chat. So please feel free to join there. And once again, guys, awesome job. Very pleased, and you've named the tool I love, Pulumi, and yeah, use whatever you like. It's all awesome if it works for you. Thanks, and see you soon.
Thank you. Bye-bye.
Cool. Bye.